So we'll take this value like this, BA1 pair and then LL, OO and then N. So we have to repeated values we have to remove now. So that BA, L dummy value and then we'll take LO and then ON. So this is the final one. So what are the pairs? BA and then LX and then LO, ON. So 4 pairs are there. We have to convert this into ciphertext. So how can you do it? Check it. BA. B and A. Where is B? B is here and A is here. What happened here? Both are in
same row.
Same row. In this case, so what is the rule is saying? If they are in same row, then replace them with rightmost letters. So rightmost letter means what is that? What is the rightmost letter for A?
B, C.
What is the rightmost letter for B? C. So 1 minute. Some mistakes here. So first one is B, next one is A. So what is the rightmost letter for B? That is C. The rightmost letter for A is B. So this is the ciphertext, C and B. Okay, need not check the diagonal value. That's why we are taking this. So understood now? For B, what is the rightmost? Yes, rightmost means immediate right. What is the letter? C. For A, what is the immediate right? B. So this is what? This is plain text. This is ciphertext. That's it. So L and X. So what is the value? L is here, and then X is here. Where is X? X is here. So there is no column and also row. So that we have to take P and U. U, 1 minute, what is that? This is correct, no? U and P. And likewise,
no, sir. P.
Yeah, yes, L and X, no? The diagonal values are
Correct.
U and P. See, when you are considering this one, how we are going to replace means the column corresponding to the row, and then row corresponding to the column value. For L it is U and X it is P. So diagonal value only we have to consider here. Column corresponding to row and row corresponding to column. So likewise LO. Where is L and O? L is here and where is O? O is here. Both are diagonal values are N and S. Likewise ON. O is here. N is here. Where is N? N is here. So both are in same row. So now tell me what is the value? O and N. ON. What is the ciphertext? You write this in the paper and you can fold that paper in a circular format. Then what is the next rightmost letter? You tell me. For O, what is the rightmost letter? Likewise, we have to go now. For O, what is the rightmost? N. For N, what is the rightmost letter? E. So NE is the correct ciphertext. Not EN. Okay. How we are doing here? The same way we have to do here also. First, we have to convert the first letter and then we have to do the second letter. So this is what play for Cipher. Clear now?
Sir, elbow once again repeat, sir.
1 minute. See here. L is here, O is here. What is the diagonal value? N and S. See that. This is the diagonal value, no? This is simple, no?
Yes, sir.
Yes, sir.
Lx means diagonal values are U and V. This is diagonal, no? This is diagonal. See, L is here. Sorry. L is here, X is here. So what is the diagonal value? U and P. The same way, L is here, O is here. What is the diagonal value? N and S. These two are answer. Right? Next.
Okay.
We'll move to the transposition cipher. Rail fence. So transposition cipher, rail fence is very simple. The thing is here no replacement, no substitution. Only thing is we are going to rearrange the order of plain text bits to provide the security. So in transposition cipher, what we are doing, just we are going to rearrange the plain text bits. So the plain text is welcome to MITS. This is the plain text. So how are we doing this one? Means one way is I am writing like this. Two lines I am keeping W, E and then L, C, O, M, E. Welcome. T, O and then M, I, T, S. So after that just I am rearranging the letters. So what is the ciphertext here? W, L, O, E, O, I, S, E, C, M, T, M, T. So this is the ciphertext. This is very simple. Usually we are not using only once. In order to make more security, we have to apply this rail fence 2 times, or else we have to combine this rail fence with some other ciphering techniques, transmission techniques, so that only it will be secure. Otherwise, very simply we can guess it. Even not attacker, even a common man also we can easily guess it. Okay, so this is rail fence. And then row transposition cipher we'll see next. Second one is row transposition technique. Row transposition cipher. So same thing, we'll take it as plain text. Welcome to MITS. I'll write here. Same text. And then the key value here, we have to choose a unique number. Okay, we have to choose a unique number between 0 to 9. So we'll take here any digits, more than 3 digits it will be more secure. So we'll take here for 5 digits, we'll take randomly, we will take this value 3, 2, 4, 5, 1 like that, or any order you can take. This we have to choose randomly 5 digits number, but the number should be 0 to 9. After that, according to this number, just you write this number 3, 2, 4, 5, 1. Since this method is row transposition cipher, we are going to arrange the letters in the row wise. I am writing, see how I am writing, see this W, E, L, C, O, again second row. Likewise, row wise we are going to, first we have to fill the letters first row, then second row, third row, likewise. If it is column wise transposition, then first we have to fill the first column, second column, likewise. Welcome TO to MITS. So here 2 letters are not there, no, so that we have to fill it with the dummy letter X and Y. We can fill with dummy letters. So now how we are going to convert this into ciphertext means, see here, I have taken the numbers randomly generated number 3, 2, 4, 5, 1. No, now I am going to write this in the order. First See this, the number 1 is there, no? That column I am taking first, and then number 2 column I am taking next, then third column. I mean number 3 I have written, no? That column I am taking. I am writing here, see this. O, M, Y. This is first, number 1, this column. And then I am taking number 2, second column, E, E, T. And then this one. Just confusing, that's it. Nothing else. It is not standard format. You can create your own algorithm, your own technique, and you can name it out. That's it. Cipher cipher is there now. What is the name? Cipher is the person who found this method. That is why that algorithm is called a Cipher cipher. Cipher is a person. So OMY, like in aptitude, quantitative aptitude, you are doing all these things, no? EET, and then WMI. Then fourth one is LTS. Fifth one is COX. This is a ciphertext. So the plain text is welcome to MITS, but the ciphertext is completely different. No one can understand OMYEET, no word, no meaning, nothing. So just we are confusing. Why? In order to protect our data from attackers. Clear?
Yes, sir.
So only thing is, but that right fence cipher is there, no? That is not that much secure. So that we have to combine that rail fence into row transposition cipher or column transposition cipher, so that only it will be secure, more secure. So the purpose of converting this plain text into ciphertext is we have to protect our valuable information from the malicious attackers or third persons. So in that case, we should be very careful, and we have to make these calculations very complex such a way that the attacker will not crack it easily. But it is possible, like I told you already, if you make wood door or iron door or any other material, if you are making door and you are keeping very big lock also, for breaking the door and lock, maybe the time will be extended, but no one can say in this world we cannot break the door. The same way, in 2020 or 2040 or 4020, whatever it may be year, there is no possibility for 100% security. The thing is, we can extend the breaking time. That's it. That is the reason OTP also generated. Maybe why they are not giving this OTP for lifetime? Only 5 minutes, 2 minutes. This OTP is only enable or alive for 2 minutes, 3 minutes. The reason is whatever the encryption techniques they are using, the time for breaking that one is only 2 minutes. That is the reason they are setting the time for us as a OTP. Okay, this is the understanding behind it. Anybody have any doubt? We'll move to next. So just for sample, I have given these two techniques, but when you study for cryptography, you will learn many things with laboratory practical examples, with many network security tools also there. SNART tool is there, it is there, it is available in your syllabus also. If you are really interested in this hacking kind of things, you can do it, many things. We'll move to cryptography now. In this syllabus, symmetric key cryptography, asymmetric key cryptography, two things are there, only two types are there, both are given in your syllabus. Just 5 minutes, I will wind up this session. Cryptography. So cryptography means secret writing. In order to write the things secretly, we have to apply two techniques. One is encryption, another one is decryption. Encryption is done at sender end, decryption is done at receiver end. So this cryptography is divided into two types. One is symmetric key cryptography, another one is asymmetric or asymmetric. key cryptography. Only two types are there. Okay, so what is the difference between symmetric and asymmetric? So symmetric key cryptography means only single key is used. Single key is used at sender end as well as in the receiver end. Both the persons are using only same key. Same key is used both sender and receiver end. That is called symmetric key cryptography. So what is the meaning here? Encryption and decryption, both we are using the same key, symmetric key cryptography. So the example is DES algorithm and then AES algorithm, triple DES algorithm. Many algorithms are there, IDEA, also all those things. So DES means data encryption standard. Encryption standard. AES means advanced encryption standard. DES, AES algorithm, both are there in your syllabus, we will see. So, but for this symmetric key cryptography and asymmetric key cryptography, we are using block cipher. What is block cipher? I told you, no, two ciphers are there. One is stream cipher, another one is block cipher. Stream cipher means we'll take each and every character and we'll convert into cipher text. But in case of block cipher means in a block by block, we are going to take it and convert into ciphertext, which means maybe one block 10 bits are there. One block 10 bits are there or 10 characters are there. We'll take 10 characters cumulatively and convert it into ciphertext. That we are going to do it in the symmetric key cryptography, asymmetric. But in case of basic ciphering techniques are there, no? Cipher cipher, Cipher cipher, Transposition cipher, and then Hill cipher. Hill cipher I have not explained. That is also popular one. So those we are using only stream cipher. Stream means bit by bit. Block cipher means block by block. Each block contains many number of bits. It depends upon the requirement. Maybe DES algorithm they are using 64 bits. We'll see that. We'll study in the next class. DES algorithm in a single block 64 bits are there. Like AES algorithm, some other 32 bits or some other things are there. 56 bits we are using. Then asymmetric key cryptography. What is asymmetric key cryptography? Here we are using two keys. One is public key, another one is private key. In asymmetric key, we are using two keys. One is public key, another one is private key. But in symmetric, only same key we are using. If you are using same key, problem is there. That is why we are moving to asymmetric key cryptography and we are using two keys. This symmetric key cryptography also called as secret key cryptography. Symmetric key cryptography also called as secret key cryptography. Asymmetric key cryptography also called as public and private key cryptography. So in asymmetric key cryptography, here sender is there, here receiver is there. Sender is using public key and receiver is using public key, but sender is using private key also. Okay. Sender is using both public key and private key. Receiver is using only public key. Like already I told you in the bank, if you want to keep your jewels in the locker, then public key is given to you and one more public key is kept with bank manager and bank manager is having private key. So until unless the bank manager's presence is there, you cannot take the jewels back. So see this, why we are using this, you know already. The same thing here also we are going to apply in case of making more security. So who is generating the key? That person is having using public key as well as private key, and the receiver will use only public key in order to decrypt it. We'll see in detail about it. Just for introduction, I have given this. So I'll overview this and then I will finish today. ஹலோ சார், இந்த கிளாஸ் எடுத்துட்டு இருக்கேன் சார். 1 hour இந்த வந்துடுறேன் சார். So this is plain text, that is original message. So this plain text will be given to encryption algorithm. This encryption algorithm is working with key. Without key we cannot. So key value. So by using this key plus plain text, this encryption algorithm will convert the plain text into ciphertext. What is the process? How this encryption will work? By using key value comma message. This is plain text message. This is the key value. By using these things, this encryption algorithm is applied. Then only we are getting ciphertext. This is the formula. Everything is very easy only. Key value plus message, original message. Then we are applying encryption algorithm. Any encryption algorithm, DES algorithm, AES algorithm, RSA algorithm, IDA algorithm. Many algorithms available. Okay, any algorithm. Then now the ciphertext is moving across the internet because it is very vulnerable to attack, very danger. So after coming out from this internet, here in this receiver end, decryption algorithm we have to use. Decryption algorithm. So this decryption algorithm will take ciphertext, first key value and then ciphertext. Then decryption algorithm we are going to apply. Then we are getting the plain text, that is message. Plain text or M. Plain text. This is the formula. So what is this key actually? This key is same key if it is symmetric key cryptography. That's what I told you. Whatever the key is used by the sender at the sender end, the same key will be sent by the sender to the receiver. When before converting this plain text into ciphertext, first the sender has to send the key to the receiver. Then only after getting this ciphertext, the receiver, here the receiver is there, na? This is sender, this is receiver. So this receiver will take the ciphertext and then use this key value. Then by using decryption algorithm, this algorithm convert the ciphertext into plain text. Then only the receiver will understand exactly what is the message. So now the question is, why we are moving from symmetric to asymmetric? Symmetric key, this sender is sending the key value first to the receiver. How this key is moving from one end to other end? Again through internet. Already I told you internet is highly vulnerable for attack. So that is the reason, if the attacker will attack this key first, then whatever the ciphertext we are sending through this network, then attacker knows the ciphertext, attacker knows the key value, then attacker will easily convert that into plain text. So this is the problem in this symmetric key cryptography. That is the main reason we are moving from symmetric to asymmetric. That is why in today's websites also, no website is using DES and AES algorithm. All are using RSA algorithm only. What is that? DES and AES algorithms are example for symmetric key cryptography. RSA algorithm is for asymmetric key cryptography. What is RSA? RSA is 3 scientists name. Shamir, Adelman. 3 scientist name is called RSA algorithm. Okay, A is not